Okay, let's dive right into this explainer. We live in a world that is absolutely swimming in information. But here's the thing. Without the right lens, all that information, it's basically just static, just raw noise. So today, we're going to look at how data science acts as that exact lens, taking all the chaos of our modern world and bringing it into sharp, actionable focus. Now, think about this. How does Walmart know exactly what to stock on its shelves before a massive hurricane hits? Do they just guess? Are they relying on some store manager's gut feeling? No way. This surprising question perfectly illustrates the real-world stakes of what we're talking about today. Because the answer definitely isn't intuition. It's a rigorous mathematical process. So here's our roadmap for mastering this seemingly complex field step by step. First, we're demystifying data science. Second, we'll look at data in the real world. Third, understanding the raw materials. Fourth, the data science cycle. And finally, number 5, the analyst's toolkit. All right, let's kick things off with section 1, demystifying data science. What exactly is it? We're going to break down this massive buzzword into its core components. And honestly, it sounds a lot more intimidating than it actually is. It's highly logical. The absolute crucial point to remember here is that data science isn't just pure math, and it's not just writing computer code either. It's actually a synthesis of 3 distinct areas. First up, you have computer science. That's what gives us the processing power, the visualizations, and machine learning capabilities. Then you've got math and statistics, which brings in your traditional statistical analysis and probability. But the real secret sauce, that's the third circle, domain expertise. You have to understand the real-world context of the data you're looking at. Just like a doctor needs to understand medical records, a marketer has to understand sales trends. Data science sits perfectly right at the center of all 3. To really ground this, let's think about something super relatable. Imagine you're checking the temperature over the last few days to decide what to wear. You might see a string of numbers, 60 degrees, 65 degrees, 75 degrees, and maybe a string of ones and zeros that represent whether or not you wore a jacket on those specific days. But on their own, those pairs of numbers don't explicitly tell you what to wear today. They're literally just historical facts floating in the void. And that perfectly contrasts meaningless historical facts against the sheer power of a data-driven decision. Because by analyzing those past temperatures against today's forecast, you're deriving actual information. You are identifying the exact temperature threshold where you, personally, start to feel cold. You've taken raw numbers and transformed them into a clear, actionable insight. Yes, I should absolutely put on a jacket today. That right there, that is the absolute essence of data science. Moving on to section 2, data in the real world, beyond the theory. Now we're going to scale things up. Let's move from personal decisions about our wardrobe to decisions that are worth billions of dollars and can literally change entire industries. Remember that Walmart question from earlier? Well, by analyzing massive amounts of historical data, Walmart made a wild discovery. Strawberry Pop-Tart sales increased 7-fold right before a hurricane. Not flashlights, not bottled water, strawberry Pop-Tarts. So now they automatically route extra supplies directly to storm paths to perfectly meet that demand. Or think about the Oakland Athletics baseball team. They used sabermetrics to analyze historically overlooked player metrics, like on-base percentages. That allowed them to recruit undervalued players and literally break the American League record for consecutive wins. It is all about finding that hidden story buried in the numbers. Which brings us to section 3, understanding the raw materials. What are we actually working with here? Because before we can find those amazing hidden patterns, we have to know exactly what kind of materials we're analyzing. The type of data you have completely dictates the analytical methods you're even allowed to use. Basically, we can categorize our world into 2 main types of data. On one side, we have quantitative data. These are the hard numbers, things we measure, like a person's height, sales figures, or temperature readings. We analyze this stuff using standard statistical methods. On the flip side, we have qualitative data. This is categorical, it's subjective. It describes attributes and characteristics. Think of interview transcripts, a long Reddit post, or even a photograph. Since it's not numerical, we handle it using thematic analysis to hunt for patterns in the actual meaning. And once we know what type of data we have to look at how it's organized. It's essentially a battle between order and chaos. On the side of order, we have structured data sets. These are perfectly organized in tabular formats, rows and columns, where every row has the exact same predefined attributes. Think of a clean Excel file for course evaluations. Easy, right?
But the real world is messy. So on the side of chaos, we have unstructured data sets. This data does not fit neatly into rows and columns. It is totally freeform and highly varied. We're talking about millions of random TikTok videos, messy Amazon product reviews, or an entire week's worth of chaotic Google search queries. Extracting meaning from all that requires some serious processing power.
Next up, Section 4, the data science cycle, a repeatable process. So how do we process all this chaotic raw material without getting completely overwhelmed? Well, we don't just dive in blindly. We follow a very precise methodology. We use a highly structured, perfectly repeatable 5-step loop to go from identifying a basic problem all the way to visualizing a complex solution for domain experts. It always starts with step 1, problem definition. What exactly are we trying to solve? Step 2 is data collection, purposefully gathering surveys or pulling digital byproducts like web search histories. Then comes step 3, data preparation. Honestly, this is often the hardest part. This is where you're cleaning the data, fixing typos, and aligning time zones just to make it usable. Step 4 is data analysis. This is where the math actually happens, ranging from simple min-max checks all the way to advanced predictive machine learning. And finally, step 5 is data reporting. This is where we translate those dense findings into beautiful charts and maps that anyone can understand. It's a continuous, flowing cycle of refinement.
All right, let's head into our final section. Section 5, the Analyst Toolkit, moving beyond spreadsheets. Look, for simple problems, a standard spreadsheet might get you through that whole cycle just fine. But what happens when you're dealing with millions of messy, unstructured data points? Let's take a look at the specific tools used in the final steps of the cycle when simple spreadsheets just aren't going to cut it.
What is really fascinating here is just how accessible this technology has become. Instead of using some intimidating matrix-style software interface, modern analysts use something called Jupyter Notebooks. These are interactive documents broken down into blocks that we call cells. Now, some of these cells just contain plain human text for narrative reporting, which makes the whole document super readable and friendly. But directly beneath that, you have code cells used to execute programming languages, like Python. So the everyday text and the complex code live comfortably side by side. It lets you explain your thought process right next to the active data processing. It's brilliant. And within that notebook, data scientists rely heavily on Python, and specifically a premier library within it called Pandas. Get this, with just 2 simple lines of code, analysts can use Pandas to instantly load massive, messy raw files, like a giant CSV file, and instantly transform them into neat, structured tables known as data frames. From there, they can easily search, filter, and generate basic statistics across millions and millions of rows without even breaking a sweat. Finally, once Pandas has structured all that data, we move on to visualization using another library called Matplotlib. By feeding those massive, multi-dimensional data frames directly into Matplotlib, it translates all that raw code into visual charts that immediately expose hidden patterns. For example, it can instantly reveal a massive positive correlation between a movie's domestic and worldwide box office success. If you just stared at thousands of raw spreadsheet numbers, spotting that pattern would be incredibly difficult, maybe even impossible. But visually, the trend line is undeniable. And that really brings us to the core philosophy of this entire field. Whether you're Walmart using algorithms to restock strawberry Pop-Tarts ahead of a major storm, or an analyst hunting for undervalued baseball players to win a championship, the tools and the math all serve one ultimate, singular purpose: turning the chaos of raw information into the absolute clarity of actionable insight. It's all about clearing away the noise so you can finally see the truth underneath. So I want to leave you with this thought as we wrap up this explainer. Look around your own business, your own hobbies, or even just your daily habits. What mysteries could you solve? And what massive advantages could you uncover by applying this structured cycle to your own world? The data is already out there. It's literally just waiting for you to bring it into focus.